Okay, so the chapter 5, if you know how to do the graphing, chapter 5 should be relatively easy, okay? Because this one is using the graphing, linear graphing, and then we will find the maximum, minimum value, something like that, okay? Let me go ahead and see. All right, so if you cannot see the screen, please let me know, okay? So just in case I'm talking that way. All right, so we're gonna look at a linear inequality in two variables in here. So the inequality, of course, the inequality you always have a less than or equal to, greater than or just greater than or equal to. And the graphing for the inequality is very, very similar to the equation. You will still need to graph the straight line first and then identify the reason for the inequality, okay? So if we look at the equation in here, graphing the inequality, suppose if I have this one is x, this one, like I said, if I suppose to say this is 2, right? And then this straight line will be x equal to 2 in this straight line in here. So this straight line basically separate the entire plane into left side and then right side, right half of plane, left half of plane. If I say x is greater than 2, will be the right hand side, will be all this one right here, okay? If I say x is less than 2, well, less than 2 will be on the left hand side, will be everything on to the left here. So this x equal to 2 is called a boundary line, okay? And if we graph the inequality, we always have to graph the straight line first, okay? So this one, the boundary line here is y equal to x. So this is a boundary line. And if I want to identify y greater than x, now I will have to go to see which part is the upper half of planes or the lower half of plane in here. And then we're going to talk about it later, okay? So for example, if I want to graph 2x minus 3y less than or equal to 6, one thing is I will need to graph this straight line first. So that is the first step. How do I graph the straight line? So that's step 1. We're going to graph 2x minus 3y equal to 6, right? And then you can set up the 2 points in here. Say if let x equal to 0, right? And then I have a negative 3y equal to 6, so y will be negative 2. So this point will be 0 and negative 2 in here, okay? And then if I set y equal to 0, I have a 2x minus 3 times 0 equal to 6. That one is gone. So I have a 2x equal to 6. So x will be equal to 3. So I have another point here is 3 and 0. So once you got 2 points, you can connect these 2 point graph with this straight line. So that is the straight line in here. So in order to graph the inequality, the first step here is you have to graph the equal sign. And then we're gonna using the second one called use a testing point, okay? Use a testing point to check which side is the true one. And I usually like to using 0 and 0 because it's easy to calculate. If this origin point is not on the line, I like to use this point. So I'm going to using this testing point to see if this point satisfies this inequality or not. So now I have 2 times 0, right? X is 0, minus 3 times y, y is also 0. Is this less than or equal to 6? And we know 2 times 0 is 0, 3 times 0 is 0, right? So 0 less than or equal to 6, which is true, okay? So this one is true. 0 is less than or equal to 6. So what does that mean in here? That means this side is the solution. this half include contain the 0, 0 point. This half is the solution, so we usually just set this half. Alright, so the inequality solution will be the entire region. This region, upper half of the region is the solution. Some people say, how about if I plug a 0, 0 in, and this is not true? If this is not true, the other side is the solution. So you do not need to retest again. If it's true, this side is the solution. If it's not true, the other side is the solution. Okay? Alright, any question on this one? Any questions so far? I want to check if you have any question before I move on, just in case. Okay, so let me check. Does anyone has any question about this? Alright, if I didn't hear you have a question, I am moving on. So if you have any question, you can type it in here, or you can just talk if you have a speaker. Alright, or you can type it in the chat section. Let me know if you have questions. Okay, so that is the inequality in here. Alright, this one right here is one more thing about this graph. If this inequality has the equal sign, like less than or equal to, greater than or equal to, with the equal sign, we will use the solid line for this one. We're using a solid line for this boundary line. Okay, if it didn't have an equal sign, if we just less than or just greater than, we're gonna use called dotted line. Okay, not a solid line. We're gonna using a dotted line, which is like that. This dotted line to represent the boundary line. Okay, so those two different ones. So look at this one right here. I want to graph y is greater than -3, and first we want to graph y equal to -3, right? And we know y equal to -3 is a horizontal line. Okay, y equal to -3 is a horizontal line here. Since this one doesn't have an equal sign, so I'm using the dotted line in here. So we're using the dotted line in here. Okay, and this one, because this one missing the x, so that means it's a horizontal line. And which part is the solution? Well, we know if I plug 0 and 0 in, right? 0, 0 is the origin point. And since I don't have an x, so 0 greater than -3, which is also true because this is a negative number, right? 0 always greater than any negative number. So that means this part is the solution, the one upper part is the solution for this one. So we're gonna just say that this part is the solution. Okay, so that is how you identify the inequality in here. All right. Okay, our next section here is the system of the linear inequality in two variables. Okay, so we're gonna look at the two variables. Look at the x plus y greater than or equal to 6, 2x minus y greater than or equal to 0. So when you have these two inequality equation, basically we need to find a solution for each one first. Okay, so we just repeat the same process for the second inequality equation. All right, and then if we find like the overlap section, the intersection of all the graph in the system is the solution. Okay, the intersection Okay, so this intersection of all the graph in the system is the solution. Alright, so if we look at this one right here, right? This one is introduced a little bit the equal sign without the equal sign in the graph. So if you look at this one right here, y greater than x minus 2, right? We graph y equal to x minus 2 is this line. if you don't have an equal sign in here, you're using the dot line. Okay, this is called a dot line here. All right, and then if you have an equal sign in here, we call this is a solid line. All right, less than y is less than x minus 2. Again, we're using the dot line in here because it doesn't have an equal sign. And then this one, y less than or equal to x minus 2 is a solid line, right? This is a solid line. The reason it's a solid line because you have an equal sign here, okay? All right, so that is how you identify using the dot line or solid line in here, okay? All right, so we're gonna solve this system of linear inequality in here. We're gonna graph this one right here. So how do I solve this one here? Well, we will graph the line 1, and then we're gonna graph the line 2 first, okay? So in order to graph the line 1, I need to have 2 points. So I set up my x and y have 2 points. So basically, I'm graphing x plus y equal to 6. This has an equal sign, so we're using a solid line. This also have an equal sign, so we all use a solid line for both of them. All right, and I can say that x equal to 0, right? So 0 plus y equal to 6, so y will be 6. If I let y equal to 0, my x must be 6. Okay, so we're gonna go ahead and graph this one right here. Not quite straight, but you got an idea. All right, so I'm gonna say this is 6. So this is 6 and 0. And then this one here is 0 and 6, right? So we have a 0 and 6. And then we're gonna graph this line. Since we have an equal sign, so we're using a solid line. Okay, so it's a solid straight line in here. And then we're gonna come back to identify the inequality. So is this lower part or upper part is the solution. And we're gonna using a test point for x plus y greater than or equal to 6, right? I said that earlier, I like to using 0 and 0 because it's easy to calculate. So if I let x is 0, y is 0, these two 0 greater than or equal to 6, which is what? False, right? This is not true. 0 is not greater than or equal to 6. So what does that mean? That means the lower part is not a solution. So my solution here should be in this part. This part is the solution. So I don't have to retest again. I will know 0, 0, this side is not a solution. So since this side is not a solution, the other side must be the solution. Because this line just separates this entire coordinate into 2 regions, upper and lower part. Okay, and then we're gonna repeat the second one, the same process for the L2. So we're gonna graph 2x minus y equal to 0. Okay, same thing, we set up the x and y. If you let x equal to 0, y must be 0. Look at that. 2 times 0 is 0, right? So 0 minus y equal to 0. So, and then so I cannot make a y equal to 0 again because when y is 0, x will be 0, right? So I'm gonna let y equal to 2. Okay. So now I have a 2x minus 2 equal to 0. Look at that. If I let y equal to 2, I'm gonna find the x. Or if you like to have an x first, that's okay. Let's go ahead and if you let x equal to 1, let's find out the y. Okay, so x equal to 1, we have a 2 times 1 minus y equal to 0. And then you add a y on both sides, so y must be 2. Okay, so this point x is 1 should be right here, less than 6, right? Y is 2, should be right here. Okay. So we have a 1 point right here, 1 point right here, and then we also have a 0, 0 in here. So we have these 2 points, 0, 0, 1, and 2, right? And we're gonna connect these 2 points together. We're gonna connect these 2 points together and then extend them. is standard length. Okay, so this is my L2, this is my L1, L1 is the first one, this is my L2, okay? Not quite straight, but you got an idea. Now we cannot use 0 and 0 because this point, this line passes 0 and 0, right? If we use this one, they're gonna be equal. So we do not know it's gonna be greater than 0 or not. So we're gonna have to use any other point. So where's any other point? Well, any point is not on the line, right? So I'm gonna pick up this point, like I said, -3 and 0, okay? And if you don't like a negative, you can pick another point right here. You can pick a 6, 0, this side. So if I pick a -3, so we're gonna have a 2x minus y greater than equal to 0. X, so I pick -3, y is 0. So 2 times -3 minus 0 greater than or equal to 0. This will be 6 greater than or equal to 0, which is false, right? Negative number cannot be greater than or equal to 0. So that means this is false. This side is not a solution. So my solution should be on this side, the other side. Okay? And what is the solution for this entire, for the L1 and L2? And then we're going to look at the common solution. So the common solution here will be not under this one, so not in here, not in here. Ooh. Alright, I should undo this one because it just, let me go ahead and undo this one. Alright, so my solution here will be the common part. So where's the common part? Common part is right here, this one right here. So this will be the common part solution. Look at that. It's between these two lines in here, okay? And then keep going on, keep going up. So this part is the solution from here to here and up here, okay? I'm just gonna give you a little bit of shade in here. So this is the common area, not this part, not the upper lower part. So this, because this is the intersection of these two solutions is the final solution for this system, okay? So this one is the solution. So that is how we find like the solution for this inequality. And some people say, how about if I have three lines? Same thing, if you have a third line, you're gonna graph the third line in here and then identify the solution for the third line, and then you're gonna look at the 3 area intersection, okay? Not just 2 areas, 3 area intersection, and that will be the solution, okay? Alright, so if you look at this one right here, this is a little bit clear, but it's the same one we have earlier, okay? And how do we know we have an intersection? I just graph this one right here, right? And if I graph this one, we have a one intersection point. So how do I find this intersection point? This is a little bit clear solution reason in here. The intersection point is found by solving the system as the equation, right? So we have you can solve x plus y equal to 6, 2x minus y equal to 0. You can using the addition method. This one, if you use the addition method, will be really easy because you have a positive y, negative y cancel out, right? So 3x will be equal to 6x. Add these two together, add them together, and then x will be equal to 2. And then if we put x equal to 2 in here, y will be 6 minus 2, or y equal to 4, right? So that's why you have a 2 and 4 as the intersection point. In here, you can also use the matrix to solve this one if you have a little bit more complicated equation. But this one is so easy, so you can just using the addition by elimination method and then solve for x and y. Otherwise, if it's a little bit more complicated system, you can put in using the matrix, right? We talked about the matrix last class. and I will show you a little bit later as well. Okay, and so that one is the solution in here. Okay, this one, the intersection point is called a corner point. A corner point of the solution region is a point in the solution region that is the intersection of the two boundary lines. Okay, so this one is the corner point. Actually, we can say there's another corner point right here. This point is also the corner point. Okay, because this is the region, right? So we have one corner point right here. Not quite corner point because this one, okay, I take it back. This is not the corner point because we do have this region extended in here. So this is called a unbounded region. Unbounded region. Okay, the region is unbounded because this can keep going on, this can keep going down. So we only have one corner point right here. And then if we look at some other system, we're gonna have a bounded region and we're gonna have more corner points. Okay. All right, look at this one right here. Solving the system of the linear inequalities graphically. So how do I graph this one? This one has three systems, right? Three inequalities in here. Plus x must be greater than or equal to 0. Y also must be greater than or equal to 0. So what does that mean in here? If we look at this system, x will be greater than or equal to 0. Okay, if we look at this system here, x we are greater than 0, so that means the upper part, only the upper part. Y must be greater than equal to 0, that means the right hand side part. So basically this limit, this will be just in Q1, fourth quadrant. So when x is greater than, x is positive, y is also positive, that means it's only in Q1. So we're gonna graph everything in the fourth quadrant, not here, not here, not here, only the fourth quadrant in here. Okay, so that would be x is greater than or equal to 0, y is also greater than or equal to 0. All right, so if you have a graph extended to the second, third, or third quadrant, you're gonna eliminate. We're gonna just consider the fourth quadrant only. Okay, so that is what this means in here for this limitation. All right, so we're gonna go to graph the first one. So we have a 2x plus y equal to 22, right? And very similar, we need 2 points. So we need x and y. If I have x equal to 0, my y will be 22. If I let y equal to 0, I have a 2x equal to 22, so x will be 11, right? So we have a 0, and 22 right here. And then this one will be 11 and 0. And I'm not going to extend this to there because I only need a fourth quadrant, right? I only need a fourth quadrant. So that is the graph I need in here. So this is my L1. This is my L1 in here. Okay? And we're going to look at which side is the solution. So if I put a 0 and 0, 2 times 0, look at 2 times 0 plus 0 less than or equal to 22. That means it's true. So true, that means this part is the solution, okay? And then this we'll just look at this. This is the solution region will be just this triangle. I'm gonna call this is A, B, and O. OAB. This triangle is the solution for the L1 here, okay? And we're gonna go to look at the L2. So L2 in here we do the same thing, okay? We're gonna do the same thing for L2. We are going to graph x plus y equal to 13. Again, this all got an equal sign, so you're gonna have a solid line, right? So you can have x and y. X is 0, y is 0, x will be 13. X is 0, y will be 13, right? So 13 is greater than 11, so must be outside. Okay, we're gonna call this C here is 13 and 0. And 13 is less than 22, so must be somewhere right here. So that's 0 and 13, right? And then if I graph this one right here, this will be my L2. Okay, so this is my L2 in here. All right, so let's see if I using 0 and 0, 0 plus 0 less than or equal to 13, right? I using the testing point 0 and 0 since this point is not in the line, so I can use that. That is also true. So that means this inner part is the solution. So now we limit this one a little bit inside here, okay? All right, so we're gonna oh, I keep touching that one. Okay, so the solution right here will be limited to from here, from the second line, okay, from the L2. So this part is no longer satisfied, and then this part is not satisfied. But we have another point here. We're gonna call this point is D. Okay, we have a non L1 L2 intersection point is D. All right, we're gonna go to graph the L3 in here. So same thing, how do I graph L3? We set up the X and Y, right? If I have X equal to 0, this will be gone. I have a 5Y equal to 50, so Y will be 10. And then if I have a Y equal to 0, this will be gone. So we're gonna have a 2X equal to 50, 2X equal to 50. So X will be 25, okay? So how do I fit this one? I have a 0 and 10, 0 and X is 0, Y is 10. Remember this is 13, so this must be lower. Okay, so this one is 0 and 10 for the L3. All right, and then we have a 25, which is much bigger than this one right here. So I'm gonna extend my X value. Okay, so the X must be somewhere, 25 must be somewhere right here. That's 25 and 0. So if I graph this line, this is how it look like. Okay, all right, and this is my L3, right? So if I using 2x plus 5y less than or equal to 50, if I using 0 and 0 as my testing point, so 2 times 0 plus 5 times 0 less than or equal to 50, this 2 times 0 is 0, so 0 less than or equal to 50, which is true. So that means this inside is the solution, okay? But we have to satisfy all this. So this is called a mounted region, mounted because we have this area is mounted, not in an open area. So what is my solution? My solution region will be just right here, okay? All this intersection right here. This is my mounted region. That is the solution, okay? Because when I do the testing, everyone is 0 and 0 is all true for all 3 lines. So this one is the solution, okay? So let me see if I have a little bit of clear picture in here. All right, so this one is the same one, the line 1, line 2, line 3 we just went through. This is a little bit more like clear because I graph this one by hand, so it kind of looks like this intersection all in one point, but actually it's not. Okay, if you using the ruler graph the straight line, it will separate that one. But this is called a mounted region. So how do I find the corner points for this mounted region? In here we have a 0. Okay, so this is my mounted region, right? We call this one is let's call this one is L1, L2, L3 for these 3. Okay, so the mounted region here we have a 0, 0. We call this is O, and then we call this is A, B, C, and D. Okay, so the mounted region here is O, A, B, C, D. Okay, O, A, B, C, D. This O, we know the coordinate is 0 and 0, right? And then we know this point, this is the green line, intersection with the y-axis. So this point is already known, 0 and 10 is already known. This point is the L1, which is 2x plus y equal to 22. When y is 0, 2x equal to 22 or x equal to 11. Okay, so this point here is 11 and 0. Those point is already known. So we can find the 0 O point, we can find the A point, and then we can find the D points very quickly. One thing is, how do you find a point B and C? Okay, this is intersection, this is the intersection. So this is the corner point. And you will know in the next section why we need all these corner point. Okay, because we can find a minimum maximum value for that. But how do I find the corner point for B? How do I find the corner point for C? Okay, so if you look at the point B here is the line L2 and L3. So B is a L2, L3 intersection point. Okay, this is the intercept. This is the intercept for L2 and L3. So we are using x plus y. Okay, I will using the x plus y equal to 13, 2x plus 5y equal to 50 to find this intersection point. Okay, and if you want to find the intersection point for C, this is L1 and L2. L1 and L2 intersection, right? If you look at the C here, is the blue and the red one. So we're gonna have a L1 here is 2x plus y equal to 22, and then the L2 here is x plus y equal to 13. Depends on how you're gonna solve this one. If you want to use the matrix to solve, that's fun. But for the second one right here, it will be very easy to do the subtraction. You can find this one by using the first one minus the second one, right? So, but if you don't, so if I using the first one minus the second one, this is my first one, this is my second one, using 1 minus 2. Okay, so 2x minus x will be 1x. Y minus y is 0. And then 22 minus 13 is 9. So I have x equal to 9 in here already. And then x plus y equal to 13. So y will be 13 minus x. And x equal to 9. So y will be equal to 4. So that is how you find this intersection point in here. For the C is 9 and 4, right? For this one right here, you're gonna using an addition method, which is not as easy as this one because this has a different coefficient. So I'm gonna try this one using the matrix. Okay, so I write down this one is a matrix 1, 1, 13, and then that's 2, 5, 50. Okay, so we're gonna review the matrix we used that last class to find this one, because sometimes some intersection point will be a little bit challenging. So we will go to the calculator. All right, so let me go ahead and clear this one. Second matrix, okay, and then you're gonna go to edit, and then we have a 2 by 3, which is right. That's our matrix size, okay. And let me go ahead and try to see what is my equation here. I already forgot. Okay. All right, so we have a 1, 1, 13, 2, 5, 50. 1, 1, 13. 2, 5, 50. Hopefully I Remember that, right? Okay, so that is my matrix in here, and then we're gonna go to matrix math, right? And we remember we use this one, load reference, the easiest one, and then we hit enter, and then we go to find the matrix. Okay, so our matrix is in A. Okay, and I close my parenthesis in here. Oh, hold on. I didn't go back to the main screen before I do that. So I input that, go to second matrix, go to math. Okay, go to the load reference. Make sure you have to exit to the main screen to do that. And then I input the matrix A in here. Okay, so I have a 1x plus 0 y equal to 5, 0x plus y 1y equal to 8. So basically this is telling you the solution x is 5, y is 8. Okay, so that is our solution right here. X is 5, y is 8 in here. So that is using the matrix to solve this one for the corner point. If you don't want to use the matrix, you can use the substitution method, solve x for this one, plug it into the second one. Or you can multiply the first one by -2, right? And then you have a -2x, 2x cancel out. But sometimes on the question a little bit more complicated, using matrix would be the easy way to solve the intersection. Okay? Alright, any questions about this one? Let me check anyone has any questions. Okay, I didn't see any questions. Alright, so let's go ahead and move on to the next in here. A solution region of the system of the linear inequality is bounded if it can be enclosed within a circle. If we cannot be enclosed in a circle is called unbounded. Alright, so we can see this one right here is bounded because I can drop a big circle in here, So this all sides are contained by the line in here, so this is called bounded, right? If I have this open area, it will be the unbounded. Okay, so that is what I mean in here. Alright, so we usually have a little bit application in here. Alright, so that is application in this case. A patient on a brown rice and skim meal diet is required to have at least, okay, now you have to know what does at least mean. At least 80 calories and at least 32 grams of protein per day. Okay, each serving of the brown rice contains 200 calories and 5 grams of protein. How many servings of each food should be eaten per day to meet the minimum daily requirements? Alright, so if you are a nutrition specialist, very strict diet in here, right? So at least, that means it's greater than or equal to. You will have at least 800 calories in here, and then at least 32 grams of protein. Okay, and the brown rice you have a 200. So how do you do this one right here? That means you will need to set up a table, right? Usually set up a table in here, and then set the unknown as x and y. So if you do not know how many serving of the rice you need to eat and how many serving of the protein you need to eat, so you can say x is the number of the daily serving of the brown rice, and y is the number of the daily serving of the skim meals you need. And since the brown rice is 200, right? So you're gonna have a 200x, okay? And let's go ahead and look at this one right here. Okay, set out a table in here. The brown rice is x serving, skim meal is y serving, right? And the calories for the brown rice is 200 per serving. For the protein is 5 grams per serving. For the skim meal also, skim meal also have a calories and the protein, and that is the minimum daily requirement. So that means you will have to be greater than or equal both of them. So this one, the minimum calories requirement, so you have a 200 servings of brown rice, so be 200x plus 80y, this should be greater than or equal to 800, okay? And minimum protein requirement, all right, it's brown rice plus skim milk, right? So very similar, I'm gonna write down in here. So this is 5x plus 8y, this should be greater than or equal to 13. So that will mean the protein requirement, this mean the calorie requirement in here, okay? So basically the application, you will just have to set up the inequality on your own. And another invisible right here is x must be greater than or equal to 0, y must be greater than or equal to 0. The reason is that because x is the number of the serving, y is also the number of serving of skim milk. Okay, x is number of the serving of the brown rice. So the application here implies the x, we don't want to have a negative serving, right? What does negative serving? Number of the serving means, so it doesn't make sense. So that means you can have a 0 serving of the brown rice, and but you cannot have a negative number. Same thing as the skim milk, right? You can have a 0 serving of the skim milk, but you cannot have a negative 1 or negative 2 serving that way. So these two conditions you will need to add it in this case, okay? And then we're gonna do the same thing. We're gonna graph this one in here, okay? So we will go to graph these two in this case. Each one in here. If I want to graph the first one right here, I can simplify a little bit, right? Maybe I can 200x plus 80y greater than or equal to 800. Maybe I can divide by both sides by 20. Look at that. I can divide by both sides by 20. Since the number you divide by is a positive number, so it doesn't change the inequality direction. So this divided by 20, actually I can divide it by 40. I can actually divide it by 40. Okay? So this divided by 40, this will be 5x. 200 divided by 40 is 5x, and then this will be 2y, right? Greater than or equal to, this cancel out, this will be 20. Okay, so instead of graphing this big one right here, I can simplify. These two are equivalent, right? If I graph 5x plus 2y greater than or equal to 20, is the same thing as this one. Because if you multiply 40 on this equation, you're gonna get this one back. Okay, so that is the same one. So the reason you're using this one, the number is a little bit smaller, so a little bit easier to graph. Plus, if you want to solve this one, look at it. If you can solve this one in here, after you simplify, it's very easy to solve this intersection point. Look at it, I have a 5x, right? I have a 5x and 5x are the same plus 2y and then equal to 20, and then this is using the equal sign. Using the first one minus the second one, I have a 6y equal to 12, so y equal to 2. I can find the y right away, and then I can plug it into one of these to find the x very quickly. Okay, so that's the good news, is using a simplified method, you can find the intersection point really quick. Okay, so to graph the L1, we call this is L1. I need 2 points, right? So we need a x and y. If I have x equal to 0, I'm gonna have a 2y equal to 20, so y will be equal to 10. So 0 and 10 right here. 0 and 10, so this is L1, 0 and 10 right here. And then I did a y equal to 0, I will have a 5x equal to 20, so x will be equal to 4. So I have a 4 and 0 right here, so this point is 4 and 0 for this point right here. Okay, alright, so same thing, I can go to find my L2 in here. My L2 here is 5x plus 8y equal to 32. So if I might have x equal to 0, this 0 is gone, so I have 8y equal to 32, so y will be 4, right? So this point here is 0 and 4, right here, okay? Same thing, if I let y equal to 0, I have a 5x equal to 32. So 32 divided by 5 is 6.4. So about right here, 6.4 right here and 0. Okay, so that is the non-L2. All right, and we already found the intersection point earlier. Look at it, it's 3.2 and 0, right? Using this equation and this equation to solve the intersection point. So what is my solution region? If you go to using the 0 and 0 as my testing point in here, 0 plus 5 times 0 is 0, 8 times 0 is also 0, greater than or equal to 32, which is false. So false, that means the other side is the solution. Look at that, it's pointing out here, this side is the solution, the upper part. Same thing, if I using the 0 and 0 for the line 1, 0 plus 0 greater than equal to 20, which is also false. So that means this part is the solution, this part is the solution in here. Okay, and then we have this corner point right here. We also have a corner point. So this corner point would be at 0 and 10, and then B here is 3.2 and 2, and then C here is 6.4 and 0. So we have a 3 corner point. Okay, 1, 2, 3 corner point right here. And this is called open region, or called unbounded region, because it's not bounded. This can keep going on and on. So that's an unbounded region in here. Okay. All right. So in order to have this one right here, this is greater than or equal to. So what is my solution in here? Well, I have 3 solutions. Okay. I have a minimum, you can have a 0, x is what? X is the brown rice, and y is the skim milk. So you can have a 0 brown rice and 10 serving of the skim milk. It will serve the purpose. Or you can have a 3.2 serving of the brown rice, 2 serving of the skim milk. Or you can have a 6.4 serving of the brown rice, 0 serving of the skim milk. They all work. They all meet this minimum requirement, right? And anything, if you have like I said, if I have how about if I have some people say, how about I have a 10-10 right here? Okay, this point will be 10-10 right here. Well, 10-10 is also in the solution region. So that means if you eat 10 serving of the brown rice and 10 serving of the skim milk, it definitely over, above this one, right? It will above this requirement. So that's all good. Okay, so that means this one is an open solution region. All right, any questions? Let me go ahead and check to see if we have any questions. Okay, I don't see any questions so far. All right, so we're gonna go ahead and look at the last section for the chapter 5.3. 5.3 here, the good news is this chapter we only require 3 sections, right? So 5.3 is nothing new but include the first and the second section together, okay? So we have a linear programming, and then basically put everything together in this case. Okay, let me give you a scenario here. Production scheduling, right? A manufacturer of the lightweight mountain tents make a standard model and expedition model in here. Each standard tent require 1 labor hour from cutting department, 3 labor hours from assembly department, and then each expedition tent requires 2 labor hours from the cutting department, 4 labor hours from assembly department. Okay, the maximum labor hours available per day in the cutting and assembly department are 32 and 84 respectively. Okay, if the company make a profit of the $50 on each standard tent and $80 on the expedition tent, how many tens of each type should be made each day to maximize the total daily profit. Alright, so this one right here is we have a new one here is we want to have a maximize total daily profit. Okay, so we have a this one more equation in here is called a daily profit in here. Okay, alright, so this one, this daily maximum daily profit, this is called an adjective function, adjective equation to maximize the profit in here. Okay, because the profit amount differ from two types of tint, and the management must decide on how many of each type should be made, right? And if we do not know, we always set unknown as x and y. So if we say x is number of the standard tint produced every day, y is the number of expectation tint produced every day, and what is the profit function? Well, the profit function will be you make $50 on a standard tint, on a standard one. So $50, $50. This one you're gonna make $50. The other one is $80. So my profit function or adjective function, we can say P will be equal to 50x plus 80y. Okay, that's my adjective function or my profit function, and I want to find a maximum value for this one. Okay, alright, so that is the whole objective for this equation, and then we're gonna have to go to look at like according to this availability, you have a 32 hours cutting department can have, and 84 hours assembling department can have, right? And then we're gonna go to see how many we can make in here. So it will be really easy to make a table. Okay, make a table in here. So labor hours per 10 standard model and expectation model in here, right? Cutting department, you can have this require 1 hour, this require 2 hours. Assembly department, standard one require 3 hours, expectation model require 4 hours. And that is the maximum labor day available. So what is the maximum labor day? Maximum, that means you have to be less than or equal to. You cannot be greater than, you cannot be greater than 32, you cannot be greater than 84. So that is the maximum bit in here. And then we have this is x, so we have this is x, this is y, right? So you're gonna have a 1x plus 2y should be less than or equal to 32. And then this is 3x plus 4y should be less than or equal to 84. Okay? And the adjective function P here, we said that earlier, this will make a $50 profit. So we have a 50x plus 80y. So that is the adjective function or the profit function here. Okay? And then we're gonna go to look at these two, solve for x and y, and then plug it into here. And then we can find the maximum value for this one. Okay? So we have and that is the one we talked about earlier, and of course this x and y must be greater than or equal to 0, because this is application, right? This is how many you can make for each one. X is the number of the standard one, y is the number of the expectation tint in here. Okay, so after setting up this whole thing, we're gonna just go ahead and solve this one right here. So let me go ahead and copy this one to here. So let's go ahead and graph this one first. Okay, graphing this one, which is very similar to the one we did earlier. Okay, since x and y have to be greater than or equal to 0, so we're gonna just graph in the Q1. So that is this one being in the fourth quadrant only. And this is L1, this is L2. So L1, I make a x and y. When x is 0, we have a 2y equal to 32, so y will be 16. When x is 0, y will be, y is 0, x must be 32, right? So let me go ahead and make this is a little bit bigger. All right, so Alright, so we have x is 0, y is 16. So this point is 0 and 16 in here. And then this one is 32 and 0. Okay, so that is my line in here. And I can using 0 and 0 to do the testing point. So 0 plus 0 less than or equal to 32, which is true. So that means this side is the solution, right? That is for L1. Okay, for L2, similar, L2, we have x and y. X is 0. We're going to have a 4y equal to 84. So y will be 21. Y is 0. I have a 3x equal to 84. So x divided by, this will be 26. 28. Okay, that is 84 divided by 3, right? So that is 28, okay? Alright, so we have a 0 and 21. 21 is greater than this one, so it should be on the top. So that's 0 and 21, and this is my L2, right? And then we have a 28, which is less than 32, so must be somewhere right here. 28 and 0. Okay, so when I graph my line 2, that is my line 2 in here. So we have, if I using 0 and 0 as my testing point, 0 plus 0 less than or equal to 84, which is true. So my corner point right here will be right here, A, B, and C. And this one is no longer a solution. So my solution is right here. Okay, so I have a 0, A, B, C as my corner point. Okay, and we have of course we know 0 here is 0 and 0, right? And then we know this point here is 0 and 16. We know C point here is 28 and 0. The only thing we do not know is the B. Okay, so how do I find the B? We need to solve this equation to find the B. Okay, x minus 2y equal to 32, 3x plus 4y equal to 84. Alright, so we're gonna go to solve this one. You can do any method you want to solve this one. If you don't want to solve by hand, you can always using the matrix. So that's 1, 2, 32, 3, 4, and 84. Alright, so using the matrix as the one we did earlier, I'm going to show you a little bit clear picture in here. So this corner point right here, if you go to solve, is 20 and 6. Okay, 20 and 6 right here. And then we have this point right here, 0 and 16. Look at that. We have a 0, 16, 28, 0 right here, right? 28 and 0 right here. So you can use any method you want to solve this one is 20 and 16. And what we're gonna do here is we're gonna set up a table and then calculate all the p-value in here. Okay, set up a table, find a p-value. Okay, so let me see if I have a table right here. No. Okay, so let me go ahead and make this as a table. Alright, so I have my p equal to 50, 50x plus 80y. So we're gonna go to look at x and y, and then we're gonna find a p-value, which p is equal to 50x plus 80y, right? And then we're gonna go to look at the point here is 0 and 0. Of course, 0 and 0, p will be 0. And then we're gonna have this corner point right here. We're gonna have a 28 and 0. Okay, 28, 0. Okay, that's one point. And then we have another point here is 20 and 6. 20 and 6. Alright, so that's another point. And then the corner point right here, this point is 0 and 16. So 0 and 16. And then we're gonna plug it in here to do the calculation, and then we're trying to see which one is the maximum. So we want to find the maximum value of the p, right? So if you plug x is 28 here, that's 50 times 28 plus 80 times 0. So you can give this one a quick calculation in here. 28 times 50, we are giving you 1400, okay? And then this one will be 50 times 20 plus 80 times 6. So that is 1000 plus 480. So that's 1480, okay? And then this one right here is 50 times 0 plus 80 times 16. Alright, so 80 times 16, we are giving you 1280 in here. Alright, so which one is the maximum? We can go to look at it. This will be the maximum. Okay, this is the maximum value for the P, right? This is a P value. So that means when you produce, when you use 20 in a whatever 20 x and y. Okay, so if you choose the schedule 20 for 20 and 10, make the maximum profit in here 1480 profit in this case. Okay, so 20 and 6 make the maximum profit in here, fit into this schedule. All right. Okay, so that is how you find the maximum value for the P in here. All right. Okay, so a little bit optimal solution in here is if you have a feasible region of the linear programming is mounted, you're gonna have a both maximum and a minimum value, that way. If it's if the feasible region is unbounded and the coefficient or adjective function are positive, then the minimum value of the adjective function exists, but the maximum does not exist. So basically, you don't really have to remember all of this because we can graph them and look at it. So look at this one right here, minimum and maximum value for the function g is subject to this constraint. So when you have a g is 3x plus y, and then you have to satisfy all these conditions, right? If you go to look at all these 1, 2, 3 lines, and then in the fourth region, fourth quadrant, x and y has to both x and y has to be positive, and then you're gonna have a 1, 2, 3 corner point in here, okay? So once you have all these 3 corner points, we can find the maximum value for the z because you can just plug the x and y in here and then find a z. Z is 3x plus y, right? So we have a 3 and 6 in here, we have a and 4 in here, and then we have a 2 and 16 right here. So you just plug all this into z value and then try to see which one is the minimum, which one is the maximum. So that is pretty easy. So that's 3 times 3 plus y is 6, right? 9 plus 6 is 15. And that's 3 times 8 plus 4. So that's 24 plus 4 is 28. And then that's 3 times 2 plus 16. So that's 6 plus 16 is 22. All right, so we know this will be the maximum, this one will be the minimum. Okay, so that is this one. On the region is mounted, you have a both minimum and a maximum value. So this one is the minimum, this one is the maximum. Okay, so that is this one right here. So basically graphing is very important, okay, because once you graph them, you can identify the boundary in here. All right, look at this one right here. Do we have a minimum or maximum subject to here? If you look at this one right here, this is called an open region or unbounded region because this one can keep going on, right? This side is not bounded. Both x and y is greater than equal to 0, which is in the Q1. Y is less than or equal to 20, but it didn't have an x limitation in here, so this can keep going on. This can keep going on. So this is called unbounded region, okay? So when you have a unbounded region in here, there's no maximum value. You have a minimum value but don't have a maximum value. Okay? Alright, so you can go to find this pocket in a corner point in here, and you can find the minimum value for the z. Okay? Alright, so basically that is evaluate the objective function. Let me see if we have a last example, or this is the last example in here. It's like this is the last example. Okay, so if we already have this one right here, we can go ahead and find a z. Okay, z is 10x plus 20y. Have to subject to all of these constraints in here. So we have this corner point here. This is 0 and 20, right? And then we have another point right here is 0 and 18. Okay, and then we have this point here is 4 and 6. Okay, and then we have another point right here is 16 and 0. Alright, and then that's it, because this can keep going on and on. This can keep going on forever. So we're gonna find this one right here. This is 10 times 0 plus 20 times 20. So this whole thing is 0, so this will be 400, right? And then this one will be 10 times 0 plus 20 times 18. So that's 360. 10 times 4 plus 20 times 6. So that's 40 plus 120, or that's 160. Okay? And then that's 10 times 16 plus 20 times 0. And then this is gone. So that's 160. Alright, so if we look at this one right here, we have 160, 160. This is the minimum value. So this one is the minimum. For the z is 160. This 4 and 6, 16 and 0, this is also a minimum value. So these two are the minimum value. Okay, these are the minimum value for the z, and there's no maximum value because this can keep going on and on forever in here. Alright, so that's it. That is our chapter 5. Basically, a lot of graphing, in this chapter 5, and find a corner point, find the intersection point, and then calculate this called the objective function. Whatever the objective is, you want to find a minimum or maximum value for the z, that's called the objective function. Alright? Okay, so that's it for tonight. Do you have any questions? I am going to stop recording first.